Hi, welcome back to my class in problem solving, mathematical investigation, and modeling. Last time we talked about Polya's 4 principles of problem solving. Now we will take the same 4 principles as the 4 steps in solving mathematics problems. And I call this as the 4-step solution to problem solving that has 4 steps. Step 1 is understanding the problem. Step 2 is designing a plan of solution to the problem. And number 3 is implementing the solution plan. And the last step is looking back and reflecting on the solution. Again, the 4 steps in solving a mathematics problems based on Polya's 4 principles of problem solving are the following. Step 1, understanding the problem. Step 2, designing a plan of solution to the problem. Step 3, implementing the solution plan. And 4, looking back and reflecting on the solution. Now we will take each of these steps in great detail, beginning with understanding the problem, and we will have a set of strategies for each of these steps in solving a mathematics problem. The first step in the 4-step solution to problem solving in mathematics is understanding the problem. And these are some of the strategies that you may employ for you to be able to understand the given mathematics problem. First strategy is read and reread. Of course, for a problem solver, such as a student, a teacher, or any professional, to to understand the problem, he or she has to read the problem. And at times, the problem solver has to reread the problem more than once or many times. Sometimes the problem solver has to read the problem in silence, and at other times the problem solver has to read the problem out loud, because reading out loud may help some students to understand the problem. And in reading out loud, you may have to repeat to read the problem again and again until the meaning is made clear to you. The second strategy for understanding the problem is paraphrase the problem. To paraphrase is to state the problem in your own words. In paraphrasing the problem or stating the problem in a student by a student using his or her own words, it enables the student to better understand the problem. And number 3 is visualize. To help you visualize the problem, it is in this strategy that you employ the use of diagram, graph, or picture. And in cases that you do not want to draw a graph, a picture, or diagram, you should at least try to imagine in your mind the problem. How does the problem look like in reality? Or you have to imagine the objects describing the problem as concrete objects in reality. And number 4 strategy for understanding the problem: work in pairs or small groups. This strategy would work if the students are grouped in pairs, also known as learning cells, or when the students are grouped into small groups, then they can discuss the problems among themselves and deliberate and make discussion about the problem. 5 strategy: identify goal or unknown. In this strategy, you will now try to find what is exactly being asked in the problem, what it is that you are required to find in the problem. And number 6, identify required information. For you to, after you have identified the problem, the question that is being asked, the task that you have to do and accomplish to arrive at the solution of the problem, you need information to work towards the solution of the problem. And you have to identify what information you need or what information are required for you to be able to arrive at the solution of the problem. 7, identify extraneous information. Now, in some problems that are lifted from actual situations or problems from industries, from real work, from the real world, the problem is described in detail. such that so much information is given, but not all of them are really needed or relevant to the problem or question being asked in the problem. And you have to identify this extraneous information. They are informative, but they are not really useful for solving the problem. And so they may have to be discarded so as to prevent confusion. Number 8, detect missing information. Now, in some problems, not all information are given for the problem solver, because there are information that the problem solver must have a knowledge already, and the problem solver has to identify also what other information he or she needs to be able to solve the problem. Number 9, define and or translate. That is for understanding the problem, you have to understand all the words used in the problem. If there are words or terms in the problems that is not clear to you, you have to make use of a dictionary and find the meaning of the words or terms that are not clear to you. And sometimes you have to go back to the definitions of mathematical terms that appear in the problem, because these mathematical terms, they have meanings that apply only for mathematics problems. And if these mathematical terms are taken in different contexts, the problem may have a different interpretation. Hence, for the exact meaning of the terms used in the problems, either you make use of a dictionary or you search in your references for the definitions of the mathematical terms. Number 10, check conditions and or assumptions. In some problems, there are conditions that must be satisfied, and you have to identify these conditions, because your solutions would not be useful if they do not satisfy the conditions given in the problem. And also, there are assumptions in some problems which imply that whatever solution that you get for the problem will only work out under that assumptions made in the problem, which means that solutions of a problem may not apply to other problems, because other problems may have different assumptions. And if number 11, share point of view with others. If you are working with a peer or a classmate or in a group, share your idea or your point of view of the problem, so that collectively all your ideas and points of views will lead to understanding of the problem. And beside this 11 strategy, there are other strategies that you may apply as needed, and that is number 12, others as needed. The second step in the 4-step solution to solving mathematics problem is devising a plan to solve the problem. And in this diagram, you will see some of the strategies that are most applicable for step 2. And the first is estimate. Make an estimate of the quantities involved in the problem. make an estimation of the magnitude of the measurements involved in the problem, such as length, weight, height, and making an estimate is the starting point for making a plan that can work out to solve the problem. And step 2 is revision of the estimate. You may have to revise the first estimate and even make a revision to make another estimate. And this estimate may also be revised, but each time you revise an estimate, that is one way of making sure that you are moving closer to a plan that can work out to solve the problem. And number 3, share, discuss the strategies. In devising a plan, you will now think of the strategy or the best approach towards solving the problem, towards arriving at the solution of the problem, towards answering the question in the problem. And it is a fact that a better plan is made up if 2 or more people or persons or individuals work on a plan rather than a single person working on a plan. You will have a better plan if 2 or more students are working on a plan, because this collaboration will make exchange of opinions and ideas possible. And in that exchange of ideas, deliberation is also made possible. Those strategies that may deem impossible to implement may be eliminated during the discussion or sharing of ideas, opinions, and strategies. For one student, his or her strategy may be a great strategy, but if you share your strategy to others, the others may see a flaw or something wrong with your strategy, and you may have to consider the feedback coming from the others to whom you share your idea or strategy. And number 4 is the same strategy for understanding the problem. The first step in the 4-step solution to a problem: work in pairs or small groups, because it is in working with others that you may come up with a better plan. Number 5 strategy is explain why the plan might work. And you may do this, the explaining, if you are working with others, with your peers in a group. Upon hearing your explanation of why your own strategy might work, the others will be able to assess and evaluate the possibility of implementing your strategy. They may also see the advantages and disadvantages of your own strategy, and you also get to hear the explanations of your peers of their own strategies. And in hearing all the strategies presented in a group, the members of the group can now deliberate most likely to lead to solution of the problem will be the one that will be implemented as one of the strategies in the plan to solve the problem. Number 6, each try a common strategy or a different one. If you are a habitual, if it has been your hobby to solve problems, then you may already have some strategies learned from solving many problems before. And a strategy that worked for you in solving some problems before may also work for the problem you have at hand, because this strategy is common and it is known to have worked in solving many problems before. It can also be used, it may also be used and may be helpful, and it may help you to solve the problem that you have at hand. But you may also use a different strategy or approach. A creative, innovative person will always come up with a new strategy or a different approach, which may be more efficient and effective, though it may give the same solution. It may be more efficient and less time consuming, and that strategy, though different, may be more acceptable to implement. 7, reflect on possible solution processes. Before you actually implement the plan that you have in mind, you also consider this strategy. In your mind, you think of the processes that you will undergo in implementing your plan, and you consider what may be the hindrances when you actually implement your plan. And if there is a hindrance that may not be possible to eliminate, then you have to devise a new plan. And aside from these 7 strategies that you have in this diagram, you may also apply other strategies for devising a plan to solve a problem, such as the use of internet. Of course, the internet is one sources of many information. There is no limit to the amount of information. Some of them have high quality, and there are software available online that you may also take as part of your plan. So as needed, you may apply other strategies for devising a plan to solve your problem. The third step in the 4-step solution to mathematics problem, or 4-step solution to problem solving, is implementing a solution plan. And these are some of the strategies that you may try for this is step 3. Number 1, experiment with different solution plans. This implies that you have to have more than one solution plan. And you may also collect different solution plans. And the advantage of having more than one solution plan is for you to decide which of your solution plans is the most efficient, less time consuming, and that is the plan that you would finally implement to solve the problem. Another advantage of having different solution plans is if one solution plan does not work, then you have other plans to try. But if you have only one solution plan and it doesn't work, then you will be helpless because you are not ready with an alternative plan to solve the problem. It may also be possible that two or more of your plans will work out, giving you the same solution to mathematics problem. And upon implementation of these plans that all work out for you in solving the problem, you will select the most efficient one, the most convenient plan to solve the problem. And number two, allow for mistakes or errors. This means that there is no perfect plan. Along the way of implementing a solution plan, you might end up with an incorrect solution, because sometimes it's only in implementing a solution plan that you will discover the flaws or the limitations of your plan. And then you go back to your first strategy. You prepare to implement another plan. Number three, show all of my work, including partial solutions. This is a part of the solution plan, showing all the details of your solutions. Because in doing this, you will identify which mathematical skills you have to apply in each step of the solution. And there are problems that may require you to solve auxiliary problems, and solutions of these auxiliary problems form part of the solution of the given problem. And these solutions of the auxiliary problems are only partial solutions, but you also have to show them so you may be able to relate how the partial solution of the auxiliary problem relate to the solution of the original problem given. 4. As with the first two steps, understanding the problem and devising a plan to solve the problem. Fourth strategy for implementing a solution plan is work in pairs or small groups. This is an advantage of this strategy is there is someone to check whether you are doing right or you are heading in the right direction. And if you work with others in implementing your plan, you have others to consult whether you are using the right mathematical skill, or if you are uncertain about which of the mathematical mathematical skills is the most appropriate to apply, then you have others to consult and ask and seek advice and help. And that is one advantage of working in small groups. But you may also work independently, and you can search in your references, or you can do online search for guidance, for tips, or for a review of the skills you may need during the implementation of your solution plan. 5. Discuss with others different solution plans. And the advantage of this strategy is the others will be able to tell you which among your solution plans is the most possible or feasible to implement. And in discussing your different solution plans, they may be able with others, the others will be able to tell you which is easier to implement, which is the most difficult to implement, most tasking to implement. Because as George Polya said, there is more than one solution to a problem, but finding the solution plan that is most efficient should be the object or the goal of the problem solver. 6. Keep track and save all results and data. To keep track is to monitor your own progress. If you are solving a problem independently, you do self-monitoring of your progress. And to do that, before you proceed with other steps, with another step after completion of one step, you go back and review your solution for the step you have just completed. And if you are certain that everything is right, then you proceed with the next step and save the steps completed, just completed. And in every step of the way, all the results and data must be saved. And I already mentioned this. Save before you proceed with the next step. Save all results you have obtained from the steps you have just completed. 7. Strategy: compare attempts to solve similar problems. Now, there may be problems that you have solved in the past that are similar to the problems that you are presently solving. And the attempt you made in solving the problems before may be applicable to the problem you are solving now. But you have to be, because the problems you solved before and the problem you are solving now are only similar in some ways, you have to make a comparison of the attempt you made before and the attempt you will be making as you implement your solution plan to the problem you are solving now. because you may need to do a change in the attempt you made before so that it will be more applicable to the problem you are solving now. A. Strategy. Find solution. Do not give up. Along the way of solving the problem and implementing a solution plan, you may encounter challenges and difficulty, and these challenges and difficulties may get you stuck up and you find yourself unable to go on and proceed with the solution because you have arrived at an equation. Example, for instance, you have arrived at an equation that you have not encountered before, or that is different from equations you have solved before. But there is always a way. The important thing here is to never give up. Use your references and online websites to seek or search for a method for solving that equation or situation that you find difficult and challenging. 9. Implement your own solution. If you have an original plan of your own, a strategy that is different, and as we mentioned in step 2, you may use a common strategy or a different strategy, and this different strategy may be an invention, your invention, a product of your creativity and resourcefulness. And along with other plans that you have made with members of your group, you also implement your own solution plan independently. 10. Attempts could be as important as the solution. This means that you may attempt to solve the same problem more than once, because in doing so you may arrive at a different solution, and you may discover that in the first solution you have made, you have attempted, you made a mistake that you were not conscious about, you were not aware of, and in the second attempt you arrive at a different solution because you now have you get all the steps correct, and you make no mistake in the process of solving the solution. So at times it is advisable that you solve the problem, attempt to solve the problem more than once. And the solution that you get maybe is as important as your attempt. The solution may be right because the attempt made is correct from the start to the end of the solution. And 11, check your answers, solutions. This is one way to check if the solution you obtain is possible solution. A solution that satisfy all the conditions given in the problem and should not violate the assumptions made in the solution. And when the solution is actually implemented in real life, they are practical and possible. If they are not practical to implement, then the solutions may be discarded completely, entirely, and you try to come up with another solution. In mathematics problem, there are problems that have infinitely many solutions, and you have to evaluate which among these infinitely many solutions is the best solution, and we call this best solution optimal solution. And aside from these strategies that are enumerated in this diagram, you may apply as you need them other strategies that you know about and that can help you implement a solution plan. The last step in the 4-step solution in problem solving is reflecting on the problem, looking back. Earlier I wrote step 4 as looking back and reflecting on the solution of the problem. And these are some of the activities involved in the last step. These may also be taken as the strategies to apply or employ when reflecting on the problem. The first strategy, reflect on plan after you have made an answer. This is a way for you to decide on whether the plan you have implemented is efficient and convenient for you to implement, so that in the future when you encounter the same problem or similar problem, you will use the same solution plan. And also in reflecting on the plan after you have arrived at the answer is one way of assessing the difficulties you have encountered, and you make a plan on how to prevent such difficulties and problems you have encountered from reoccurring in solving problems in the future. The second strategy is reflect on plan while finding the answer. The difference of number 2 from number 1 is in number 1 you do the reflection at the end of the solution process, while in number 2 you do the reflection while you are in the process of solving the problem. That is, you make yourself aware of what you are doing by reflecting on what you have done, so that you can plan for the next step and correct what you have done wrongly in the previous step. Number 3, check if all problem conditions were made. As I mentioned earlier, a solution is considered as possible and may be correct if it meets all the conditions given in the problem. And all the conditions given in the problem should be satisfied by the solution. The fourth strategy, make sure I can justify, explain my answer. Mathematics is an exact science, and solutions, answers to mathematics problems cannot be possibly obtained arbitrarily. You have to be skillful in applying the mathematical skills, and you have to be confident in using these skills in writing the equations, in formulating the model, and converting the problem the word problem into mathematical model or equation. And you have to be able to explain every step of the way, every step that you take towards arriving at your solution. And number 5, check if correct assumptions were made. In many problems, the answers can be as good only as the assumptions. If the assumptions made are incorrect, that would lead to incorrect solution or answer. So you have to, when you arrive at an answer, go back to the assumptions made in the problem and check if you have used the correct assumptions given in the problem. If you have misinterpreted the assumptions, that would most likely lead to incorrect solution. Number 6, check that I answered the problem question. The answer in most mathematics problem is specific and exact, and should answer the specific question in the problem. If it does not specifically, if your answer does not specifically provide an answer to the question in the problem, then you have misinterpreted the problem, you have misunderstood the problem, and you may have to change your plan, implement it again, and arrive at an answer that provides an answer to the question asked in the problem. 7, check if answer is unique or there are others. As in solutions of systems of linear equations, the solution of systems of linear equations may be a unique solution, infinite solution, or the system of linear equations may be inconsistent. That means there is no solution to the system of linear equation. And once you have arrived at a solution to a problem, like solving a system of linear equations, you have to check if there may be just might be other possible solutions, because as I said, a system of linear equations may have infinitely many solutions. And that is also the case in solving linear programming problems, where there could be infinitely many solutions and all of them satisfy the given conditions, which are expressed in terms of constraints, particularly explicit constraints. And you have to check if other solutions are possible. Next, reflect number 8 is reflect for possible alternative strategies. You may have arrived at a correct solution, but when writing the details, the complete solution, including the partial solutions for the auxiliary problem, the details and solution are very lengthy and time consuming, and you might want to consider other strategies or approach in solving the problem. Implementing the plan more efficiently. 9. Reflect about possible more efficient process. This is what I have been telling. We are looking for the most efficient solution plan, the most efficient process or way of solving the problem. Because as Polya said, there can be more than one way to solve a problem. And all these ways of solving the same problem may lead to the same answer or solution. But we want the way that is most efficient. A solution, a process, or a plan is efficient if it takes less time for you to solve the problem. 10. Look for ways to extend the problem. Once you have the solution to the problem, you think beyond the problem. You think if the approach or plan you have implemented will be applicable to similar problems, to other problems. And you also think whether your answer or solution is practical, that is, if it is relevant in real life or in the real world. Because in mathematics, we are solving problems that are actually obtained from real life problems, except that these real life problems are converted into mathematical models so that they may be solved mathematically and systematically. And aside from these strategies that are enumerated in this diagram, you may apply other strategies as needed. Again, we have the steps in the 4-step solution to problem solving in mathematics. These steps are again based on Polya's 4 principles of problem solving. Step 1, understanding the problem. Step 2, devising a plan to solve the problem. Step 3, implementing a solution plan. And step 4, reflecting on the problem, and that means looking back. You can see that there are arrows in the diagram. We have an arrow that goes from step 1 to step 2, from step 2 to step 3, and arrows that go from step 3 to step 4. We also have arrow that goes from step 2 to step 1. That means after the completion of each step, you need to go back to the previous step. Or while you are doing step 2, devising a plan, you may need to go back to step 1, for you may have missed some information that makes it difficult for you to devise the most appropriate plan to implement. There is also an arrow that goes from step 3 to step 2. While you are actually implementing the plan, and you experience difficulties in the implementation of your plan, you may need to return to the planning stage where you devise your plan, because you may have excluded important information, or you may have overlooked strategies that are useful in the implementation of the plan. And there is also an arrow that goes from the last step, reflecting, that goes from step 4 to step 3 to step 2 and to step 1. That means reflection has to be undertaken in every step of the way towards the solution. When you reach the end of the solution and you obtain an answer, you go backwards from the last step to step 3 to step 2 and to step 1. Thus, this framework for solving problem in mathematics is described as flexible, and it is not linear. It is not a sequence of steps that starts from understanding the problem and that ends to a solution to the problem. And that completes our lesson for today. Thank you for joining me in my class today in problem solving, mathematical investigation, and modeling.